Okay, let's continue to introduce the subject about gas sensor data, wireless and remote device control, part 2. Before start our today's lessons, let's briefly introduce the uh, system framework. The GUI is developed by MATLAB APP Designer. Yeah, you can use it to send command and show the received data. And sensor is connected to Arduino, and Arduino gets send data and send it to Raspberry Pi by Bluetooth module. Raspberry Pi received the data and transferred it to PC by Wi-Fi. This is the whole system framework. Let's see the real thing. Okay, and the GUI. I have run it. Okay, this is the GUI, and this is the system construction. This part is the Arduino, and I directly connected the sensor and Bluetooth module connected on the Arduino Uno board, and the battery is also directly connected to the board on the board. Yeah, okay, this is the whole system. And this is the Raspberry Pi. Yeah, it is used as the server of the system. And the Raspberry Pi and the Bluetooth module data transmission by serial communication. And the Raspberry Pi and between the Raspberry Pi and PC. Here use Wi-Fi to data transformation. Okay, let's start the system. When I click the connect button, yeah, it will try to connect to the server. The IP is the Raspberry Pi's IP, and the port is the server port used. And okay, let's first connect the buttons. Now let's try to connect to the oh yeah, okay, I powered. Okay, it turned green to green. It shows that the connection is okay. I can connect. You can connect. Click the button to send the command ID to Raspberry Pi and to retrieve the data you want. Before you send click the wait command you want to send, you can select from here. Okay, this button is to disconnect all the connections of the system and stop the whole or data transmission. After you get the connection is okay, you can use the two button to control the LED on or off. Okay, let's the connection is okay. Let's click the LED on button. Okay, the LED is turned on, and the LED off buttons, click it and it's turned off. Okay, this is the system. Okay, first, okay, let's try to send the okay, the command. Okay, I click it. If it's okay, acting okay, it will retrieve the same data and show it real time on this area. Okay, it's shown. This is a whole system. let's start to introduce the today's lessons. Today I will introduce lesson 2. Yeah, today is the lesson 2. I will introduce the. Okay, let's first just stop the. This the data. Let's first stop the connections. Oh, first, okay, stopped it. In my previous video, I have introduced the App Designer. Use the App Designer tool to design your GUI, and I have introduced the code of the GUI. In this lesson, I will introduce the Raspberry Pi and the Arduino, the code you run in the two board. Okay, first let's introduce the Raspberry Pi. Raspberry Pi, I developed the Simulink modules. Yeah. I developed the both modules. I directly code, build, deploy, and run in the Raspberry Pi. The code. Let's first introduce the this modules. Now the TCP/IP connection in this subsystem. You can click it and see the contents. Wait a moment. Yes, slowly. Okay. Okay. This I use Raspberry Pi support package. The TCP/IP receive block. I receive the when I click this button. Yeah, it try to connect, create the connection between the PC and the Raspberry Pi. Okay, Raspberry Pi and send command. I will show you the configurations in this block. Okay, there's a status when equal 1. Okay, this is the server. The Raspberry Pi is a server, so is used as a server, and its port is 25000, and date type is uint 8 one time and one sample time. I read one date. Here I use one date. Okay, when you the date is equal 1, it shows that the received date is success. I use it, or I will use the previous data. Okay. Now the when it's okay, when the received data is enabled, it will use the received data, and I will pass over the data. That as I have said, data transmission. I use the package. The package is its format is first package header 1 S header 2 L and the package ID. The net is the data 1 2 3 4, and the last is the footer. The footer is I'll use the SOR bitwise before the from header and data as the footer. And this is the package I used to transform the data. I use the code. Is if first now I judge the footer and the header the header 1 header 2 the 83 is S the Unicode ASCII code and L is ASCII code 76 if the 3 is okay and equal 1 it says the packet is okay, received packet is valid. I use it and read the packet ID. I read it, use it. The received packet ID, I compare it with like here. I use it when is equal F1 the command ID. It will trigger the subsystem. The subsystem is here. You can see the sine curve. It will create the sine data and send it to here from to PC. You can click double click it and click it. It will change here. There. Here it will send the data to the TCP/IP send block. Yeah, it will send the data from the server, local port. Yeah. Okay, this is one that is I click the button and I select the item. It will send the command F1. Packet ID is F1, and it will retrieve the feedback, the send data to the PC. And now I will introduce the part when the packet ID packet ID equal A1 A2 A3 this packet ID this packet ID the ID is used by Arduino board C code. I have predefined one equal this one any command ID it will trigger the block. The block its function is to send the packet to Bluetooth. Here Bluetooth is serial communication. So its meaning is the package is also same package star head 1 head 2 and packet ID and data 1 2 3 4 and footer. The package is used to send to Arduino. Okay, Arduino. Okay, later I will show you the Arduino code. Yeah, when Arduino code receives the code, it will execute perform the target. That's the code. Okay, here this code is retrieved from Arduino code from a Bluetooth module. The receive the data and receive the data. I will transfer it to TCP/IP here. TCP/IP this part. I will transfer it to TCP/IP to PC. Okay, because the connection is created between PC and Raspberry Pi. Okay, this is mainly the idea and the module I have created. When you want to build and deploy the module to Raspberry Pi, first maybe you should hardware setup settings. You should set the IP address and password you have used. Then you can here okay, please wait a moment. Okay, after the settings, I will click the buttons. It will automatically to deploy and start on the Raspberry Pi. Okay. Okay, this is the settings on my system. This is the IP, username, and my address, my password I used. Okay, after the settings, I will click it. Maybe okay. Now I click it. You can after you click it, you can change it to command window. You can see the changes, the message output. Okay, after you get the report, it shows that you have successfully code generation. Now I change the it's deploy. It's okay. 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 Let's briefly describe the settings. Okay, let's here the pre-build options, build and run. Okay, this on this selection, if you select it, it will run on boot. The Simulink, the deployed this module, you have it deployed, and it will run. If you check it, it will run on when your Raspberry Pi power on. Okay, if you uncheck it, it will automatically auto run. It will not. So now I don't check it. Later I will show you how to run the Simulink modules from GUI. Okay. Okay, this is the Simulink modules. Next, I will show you the Arduino board, the code used in the Arduino board. Okay. This I created my code from in the VS Code. Okay. This in my previous video, I have introduced the environment. Use it to develop the Arduino code. Okay, this is the whole code used in this project. Okay, the core code is okay. The command ID I defined the here A1, A2. I used it as A1 is used to get the analog A0 channel 0 is data command. Command yeah, LED on off is B1, B2. It's the same as I have defined here. Okay, this the code. This the command ID you defined in Visual Studio. VS Code is I have here. I use FF is used to stop command. Next, okay, this part is used to MPU 6050 and use the various. Okay, I2C MPU 60. Let's use the I2C to configure it. This is the function, defined in this code. Our setup is the first run one time part, and the loop here is the core. I think. Okay, this part is this part is a Bluetooth Bluetooth module used as here as this function here used to pass through the packet data and get the packet ID from and package the data from the received packet. Okay, this part I can go to definition. I will show you the details. Okay, here is the parcel, the received packet by this code. Okay, the header 1, header 2. Net the package ID and the data, received data, and the footer. Okay, then the total the package received is okay. Returned 1, return true. Okay, so the returned one the true, the parcel from package is true. It shows that the Bluetooth received data from Bluetooth. The packet is valid, and when the packet is valid, I use it the packet to read the packet ID. I see because I saved it into the global variables. Okay, if the received packet ID equal the command ID, I make the flag equal 1, and maybe the LED on. I directly write the 1 to the port. Okay, this port. Okay, when the flag is true, I run the code forever until I receive the code FF the stop code. I make the various to variable to 0. Okay. Okay, this is how. Okay, this is my code that you that is right there and to the Arduino. Okay. Okay, this is today's contents I want to describe. If you want, if you have any other questions, you can let me know. I will give you answer. Yeah. Okay. Thank you very much.